Hello everyone, I am Professor Shalini Sahay from EC Department SIRT Bhopal. Today we are going to discuss the lab experiment 1 of CNTL EC 503. The first experiment, what aim is to plot magnitude response of passive low pass filter. Now we will discuss its theory. A low-pass filter is a circuit that can be designed to modify, reshape, or reject all unwanted high frequencies of an electrical signal and accept or pass only those signals which are wanted. Passive filters are made up of passive components such as resistors, capacitors, and inductors, and have no amplifying elements, transistors, op-amp, etc. So have no signal gain. Therefore, their output level is always less than input. Now, the RC low-pass filter. A passive low-pass filter required a resistive element with a reactive element. In other words, we need a circuit that consists of a resistor and either a capacitor or an inductor. So in this experiment, we have made the low-pass filter with the help of resistor and capacitor. Load is connected across the capacitor. Now, when the frequency of the input signal is low, the impedance of the capacitor is highly relative to the impedance of the resistor. Thus, most of the input voltage is dropped across the capacitor and across the load, which is in parallel with the capacitor. When the input frequency is high, the impedance of the capacitor is low relative to the impedance of the resistor, which means that more voltage is dropped across the resistor and less is transferred to the load. Thus, low frequencies are passed and high frequencies are blocked. Now the cutoff frequency. The range of frequency for which a filter does not cause significant attenuation is called the passband, and the range of frequency for which the filter does cause significant attenuation is called the stop band. The cutoff frequency of an RC low-pass filter is actually the frequency at which the amplitude of the input signal is reduced by 3 dB. The cutoff frequency of an RC low-pass filter is calculated as follows. Fc is equals to 1 upon 2 pi RC. Now for this experiment, we are going to discuss the Matlab code. Now what first command is omega is equals to, we have taken the frequency starting from the 0 and end to the 500 with the difference of 0.01. Now the gain, what is the gain of the low pass filter? We have taken as this 1./1 plus j omega. As we have seen in the diagram, R and C are connected in series. So we have taken the combination of the R and C and taken the gain. Now for the practical, we have taken the value of resistance is 1 ohms and capacitor is also 1 farad. So therefore the gain comes to be like this. Now we have plotted the gain with respect to frequency. So we want that the gain should be plotted in semilog paper, like in drawn in semilog. So we have taken the command as semilog x w, and we have taken the absolute value of the gain. Now we have plotted, it will plot this magnitude graph, and we have put the grid on. Now we have given the title as magnitude response of the low pass filter. We have labeled the X as frequency and Y label as the gain. This is the graph. In the Matlab window, we have obtained the graph of the magnitude response of the low pass filter, gain versus the frequency. Thank you.